Okay, everybody. For the third part of this review, we're going to wrap up. It says which line appears to have an x-intercept of 4 and a y-intercept of 3. Well, first off, we know when we're talking about y-intercept, we need to be looking at the y-axis, right? Y-axis. Oh, that was a little busted there. Hold on. All right, and we're looking for the y-intercept where the y-intercept is positive 3. Well, we know the y-intercept here is 1. Here is negative 4. Here is negative 2. And here, up, positive 3. This just might be our answer. But let's double check at the x-intercept, which needs to be 4. This x-intercept is negative 1. This x-intercept is negative 3. About 2.5. Up, what do you know? Positive 4. This is our answer. All right, number 4 says the table represents some points on the graph of the linear function g. What is the rate of change? Remember, rate of change, slope. That's what it means. Therefore, we're looking for slope. We choose 2 points. And then we use our slope formula where we say y2 minus y1 over x2 minus x1. So this is our x1, x2, y1, y2. So this becomes 10.5 minus 13 over negative 2 minus negative 4, which just is plus 4. So this becomes negative 2.5 over positive 2. In our calculators, we may want to simplify this so that it becomes 2.5 divided by 2, which is 1.25. Negative 1.25. That's our answer, negative 1.25. Number 5, which line appears to have an x-intercept of negative 3? An x-intercept of negative 3. Now, x-intercept means we need to be looking at our x-axis. And which one of these, when we look at it, has an x-intercept, meaning the graph crosses the line at negative 3. So, like, about right there. Well, it's clearly not this graph, right? But looks like it may be this graph. Because right there is where the graph crosses, and it is negative 3. So, that's that answer. Number 16, the graph below shows the relationship between the number of gallons of fuel remaining in a truck and the number of hours the truck is driven. Now, we know the more miles we drive, the less fuel in the tank, right? So that's what this graph is representing. It says, what does the x-intercept of the graph represent? Well, first off, here's the x-axis, and the x-intercept appears to be right here at 20. All right? Well, what's the fuel in the tank after 20 hours? It's right here on the line, so it's 0. That means after 20 hours of driving, the truck will have no more fuel left in the tank. Now, which answer choice is this? The number of gallons before driving? No. The number of hours the truck was driven before running out of fuel? Yep, it's that one. All right. Number 17, in a sequence of numbers, we have A4 is 2, A5 is 7, A6 is 12, A7 is 17, and A8, we don't know. All right, based on this information, write an equation to find the nth term of the sequence. It could be real tempting to say that this is A1, but it's not, it's A4. So we actually have to do a little bit of thinking to determine what was A3, A2, and A1. Well, first note that to go from A4 to A5, we add 5. From A5 to A6, we add 5. So we have a D, meaning common difference of 5. So what does that mean? To determine A3, we need to subtract 5 from 2. that gives us -3. Subtract 5 from -3, that gives us -8. And subtract 5 from A1, and we get -13. So our A1 is -13. Our D is 5. And to write an equation, let's remember we need to have A sub n equals A1 plus n minus 1 times D. All right, so this becomes -13 plus n minus 1 times 5. Distribute the 5 inside, and we have -13 plus 5n minus 5, which is 5n minus 18. That is the equation to find the nth term of the sequence right here. All right, last one. A sequence can be generated by using A sub n equals A sub n plus 2, where A1 is 25 and n is the whole number greater than 1. What is the first 4 terms in the sequence? Well, note that this is recursive form right here. All right, remembering that recursive form says A sub n equals A sub n minus 1 plus D, the common difference. So our common difference here is 2. If we know the first term in the sequence is 25, then using this common difference of 2, meaning the next term has to be 27, then 29, and then 31. So the first 4 terms of the sequence is right here, 25, 27, 29, and 31. Because we add 2 to this first term, and then add 2 to get the term after the second term, and so on and so forth.